Hello and welcome to this new video on recursion. We're going to cover here what is a fundamentally strong programming principle. So make sure you have visited the previous videos because, at least functions are going to be used here. So let's go ahead and see how to implement this. First of all, a little bit about the word recursion. So that comes from the word recur, which you could split as re plus occur. All right. Now this actually gives a nice insight into what actually this might be doing, which means a function occurs repeatedly. It occurs many times over. All right. So let's say we wanted to actually print out the sum of first n numbers. All right. As an example, let's say we were talking about the sum of first five numbers. So we could say that is 5 plus sum of the first four numbers. So 4 plus something, all right, and this will be the sum of first three numbers. So we can say that, okay, that is 3 plus sum of the first two numbers, all right, so that is 2 plus sum of the first one number, which is basically 1. All right. So you can think of it like this, for example, if I give you that the sum of first five numbers is 15 and I ask you what is the sum of first six numbers, you're going to make use of this information. You're going to say that, okay, sum of first six numbers is 6 plus the sum of first five numbers. So it's going to be 6 plus 15, which is 21. What you're not going to do is you're not going to calculate 1 plus 2 plus 3 plus 4 all the way up till 5. You're just going to make use of this already stored result, and based upon that you're going to give your output. So let's just make this very quick function. We'll just call this function as let's say total. So we want total up till, let's say, the number n, right? So first of all, we have to, whenever we do recursion, we have to think about the boundary condition, or the terminal cases. In this case, if n is equal to 1, we know that the sum of first one natural number is basically just 1. All right. So what we can say, if n is equal to 1, we can just return n. All right. Now this is important because there should be some terminal condition. Okay. Otherwise, what will happen is the function will keep calling itself over and over again, and there is actually no stop to this. We will run into what is called as stack overflow. All right. But we don't want that. We want the function to terminate somewhere, and that is the case over here when n is equal to 1. All right, but what if n is not equal to 1? Well, in that case, all we want to return is n plus total of n minus 1. All right, so this is the hallmark of recursion. The function whose name is total should be called from inside of the function. If you have this, you're having recursion. Otherwise, you're not having recursion. It's simple as that. All right, the function should call its own self. So let's just print this out. Print, you would remember from previous videos how to actually call functions. So you can say print total of, let's just try with smaller numbers first. So the sum of first four numbers, it's going to be 10, right? Let's just go ahead and run this. Run recursion. Again, the IDE that I'm using is PyCharm Community Edition. It's available for free for all operating systems. All right, and we're getting the nice answer as 10. Let's just make sure that it works for other values as well. If we put 6, we should get the answer as 21. All right, let's test for the terminal cases as well. If we press 1, we get 0. So sorry, we get 1. And if we put 0, we get we get some error, but it's actually fine, because we can expect as a precondition that what the user will provide is a valid, it's a valid natural number. So all functions cannot account for all conditions. You can take as a precondition for this particular function that the number entered is a natural number. So it's perfectly fine. All right, I think we don't need to worry about this condition over here. Let's just run for one fellow again, over here. Let's say for 10, we should get the answer as 55. And this is how we can do recursion. Now this is not the only problem that can be solved using recursion. I think some of the common ones that can be solved using this are that come at the top of my head right now. That's the Fibonacci sequence. All right, factorial of a number, all right. And yeah, I think these are pretty good. So you can find some additional practice materials in the description link below. All right, and if you try that, well and good. If you have any trouble, just feel free to comment over here, and I will try to resolve it. Alright, that's it for this video. Thank you guys. I'll see you in the next one.